Assalamualaikum and good day, student. In this part 11, we will look into several new concepts which related to subtopic product separation and recycle in reactive process mass balance. Okay, under product separation and recycle, we have three concepts that we need to know. That is the overall conversion, single pass conversion, and under recycle, another concept which is known as purging. Okay, just a recap from the previous part 1 to 10. So we learned about mass balance with reactive process. So we know we are dealing now with a reactor. As usual, this is a reactor and we have inlet stream and also we have the outlet stream. So from part 1 to 10, we learned about stoichiometric equations, stoichiometric ratios, stoichiometric coefficient. We learned about limiting excess reactant, how to determine whether it's limiting or excess reactant. And then we learned about the extent of reaction of the reaction. We learned about the conversion of the reactant. Also, we learned about yield and selectivity when we have multiple reactions. And we also look into the methods of solving mass balance using molecular, atomic species balance, and also extent of reaction methods. And also we also go through degree of freedom calculation for these three methods to solve mass balance. And all this concept happens relates to, when we have a reactor. So all this concept we use it when we have reactor. When we have a reaction system, process that have reactor and separation unit together as a in multiple process of reaction here. We will need to know two concepts, that is overall conversion and single pass conversion. Okay. Previously when we learned in chapter part 1 to part 10 is reaction that happens only at the reactor. So that's we only study up to this. Okay. And we know from here the concept of limiting reactant, yield, selectivity, conversion, right? And okay, from here, let's say we have this process. G to F. Okay, G react in reactor with catalyst produces F. Okay, we have 100 mole of G per minute goes into reactor, react, and it after the conversion, 75% conversion, it produces 75 mole of F. And from 75 of mole G being used, so we left with 25 mole of G per minute which is not being used. So this is our product from reactor, but this is not a pure product yet. Okay, in order for us to sell, let's say we want to sell our product F, we have to put this product F in this product line. We have to send it to a separation unit. Therefore, this separation unit will separate F from G. Okay? Right. So, from the separation unit, we'll get pure F. 75 mole of F goes there. And we will have 25 mole of G unused here. So, what should we do with this 25 mole of G? Should we throw it or actually we recycle it? Actually, we can recycle this unused G in order to increase our conversion. Instead of throwing it out, why don't we recycle it? We recycle this G here, put it back into the fresh feed, mix with fresh feed, and produce feed towards the reactor. So instead of throwing it out, so let's recycle it, use it back into the process. So 25, if this is 25, this should be 75 mole of G per minute, because 25 plus 75 mole of G, it becomes 100 mole of G that goes into the reactor. Okay. when we have this type of process, then we have this concept, overall conversion and single pass conversion. Overall conversion is the conversion of our reactant at the overall boundary. Okay? Here. When you want to calculate overall conversion, this is your boundary. Okay, so I name it as boundary 1. So your calculation of overall conversion should refer to boundary number 1. But when we go to single pass conversion, is the conversion of your reactant only at the reactor. So its boundary is here. The second boundary here. Okay? The full definition of overall conversion, please look at equation 4.7-1 in your textbook. And for single pass conversion, equation 4.7-2 in your textbook. Okay, how do we find overall conversion here? Overall conversion, okay, for this, because we only have one reactant and one product, so our reactant is G. For overall conversion is number of mole number of G used divided by number of G fed. So in this case, we will use mole because it's reactant, so it's actually number of mole. However, for this overall conversion, number of G used divided by number of G fed at the overall boundary. Okay? So, number of G used. How do we know how many number of G has been used in this process? Okay. To find this number of G used for the overall boundary, we know that goes into the overall system is 275 mole, right? 75 mole G per minute minus, do we have anything G comes out from boundary, overall boundary? No. Okay? No. It comes out from the separation unit, but it does not cross the boundary, overall boundary. Therefore, this is 0, right? Okay. So this is mole G per minute. 75 that goes into the overall boundary, but we do not have anything that goes from the overall boundary in terms of G. 75 minus 0, divide by how many of G that goes into the overall boundary is 75 mole G per minute. Therefore, 75 divided by 75, we get 1. Or in terms of percentage, it becomes 100% conversion of G. Okay? I hope you understand that. Okay, for single pass conversion, if we want to find single pass conversion is just conversion that happens at the reactor. Okay, so same for full definition, you have to refer to this equation. So I just use the summary of the definition. So number of G used at the reactor divide by number G fed at the reactor. In this case, is mole per minute as our unit, equivalent to how many moles of G is being used. We know 100 mole goes in, mole per minute of G goes in. We have a balance of 25 mole of G. So 100 minus 25 will get how many moles of G is being used. This is mole G per minute, right? The unit divided by number of G fed. Number of G that being fed into the reactor is 100 mole. Mole per minute G. Therefore, we'll get here 0.75. Okay, or in terms of percentage is 75%. From reactor, the G convert is only 75%. However, if we add in separation unit, we will obtain 100% conversion of G, because we cycle back our G into our process line. So I hope you understand this concept. So I'll give you more tutorial for you to get familiarized with this concept. Thank you.